My name's Tom Loughran. I'm a lecturer in politics here at Manchester. And what I'm going to be presenting you today is some work from my PhD that looked at a method called confirmatory factor analysis, which is known as a latent method that you use on secondary data analysis to try to get at themes and information that might not be immediately apparent from direct survey results. So what I'm going to do is I'm going to present the confirmatory factor analysis stage of a structural equation model, which is from my PhD research, which was into how people convert their values into voting preferences across 15 different Western European countries. And I'll be explaining how this can be applied in that cross-national context, which is a fairly unusual thing to do. And I'll be discussing the pros and cons of this approach, and hopefully giving you some idea of how you might go about dealing with this sort of method, and trying to give you an idea that when you're carrying out statistical analysis like this, quite some more complex or intermediate methods, you're not being driven by the data. Okay, you're still being driven by your theoretical understandings, your substantive judgments as a researcher. Sometimes there's a tendency to think that if you use statistical methods, particularly complex statistical methods, you get a bit led by the nose. So you think that it's actually about what the data shows you, and you kind of lose track of the fact that behind that is a whole set of theoretical assumptions and judgments that you're making as a researcher. So I'm trying to emphasize in this presentation and demonstrate the kind of judgments and assessments I made, and also demonstrate that what I got out of this was not a perfect model. Okay, so a lot of times when we're doing statistical analysis, we're not looking for the kind of perfect statistically perfect model. We're looking for something that tells us something about the world and that we can justify back to our theoretical assumptions and our kind of research questions. And I'll take some questions at the end about it. Okay, so first of all, why, just to put this in some kind of context of the research, so hopefully it's not too dry for you. Why was I interested in looking at values? Well, firstly, there's a long history of kind of values research in political science, and the idea that values play a key role in political outcomes, in electoral decision making, and the fact that this is a fundamental role in politics is something that has been well covered, but had not previously been looked at in a kind of cross-national context in terms of their political implications. So values tend to be seen as trans-situational underlying constructs that people use to structure attitudes and ideology and to guide decision making. The idea is that they kind of sit a step back behind the cognitive pathway to kind of ideology and attitude. So they structure people's ideological assumptions and their attitudinal assumptions. And in that sense, they're a kind of glue that holds together many ideological and attitudinal positions. And values are often perceived as competing conceptions of the good. So this is often used as a definition and relevance for studying political values. Okay, this comes down to the idea, as Easton says here, that politics is the authoritative allocation of values. So it's the way in which we settle values disputes. And I was primarily interested in looking at the relationship between values and voting. I was developing a 5-value model that looked at individualism, traditionalism, conformity, egalitarianism, and authoritarianism. I'm going to take you through the process of how I put that model together. Okay, so this was the overall model for my PhD. So I was looking, this is a very kind of basic model of it, presentation of it in terms of the figure. But what it's looking at, what it's presenting to you is what's called a structural equation model. Okay. So the structural equation model takes what we call latent concepts, in this case values, things that can't be directly observed, and then uses this to predict outcomes. So in this case, vote choice. But it has a secondary function, which is that structural equation modeling can be used to estimate a mediation pathway. So how values influence vote choice via a kind of third influence. In this case, I was looking at political identity as reflected in people's sense of left-right, okay? People's perception of their own left-right position. So my theory was that values predict left-right, which then predict vote choice. Okay, that was my theory. And that was based on that in itself wasn't particularly original. That was based on previous research, previous assumptions that had been made. But I was using cross-national analysis of the 1990 and 2008 waves of the European Values Survey, which is a large secondary data source encompassing it varies, but about 40 countries in Europe, both East and West. I concentrated on West European countries because I was interested in running a kind of least differences model that looked at how we can draw out patterns among broadly similar countries. And as you can see, I've factored in most West European countries. There's a few exceptions that aren't captured by the data for various reasons, but as you can see, most major West European countries were in my data set. And this model, as you can imagine, requires the identification of a robust political values measures. Okay, values measures that you can see that would be consistent in all 15 of these countries and across my whole pooled sample. And this creates a debate around whether values are a latent construct, so in other words, whether they can be and should be measured directly. And I was making an assumption that they are a latent construct. So we can identify these ideas of values from other directly observable variables. Values are conceptually fuzzy in this sense. There is a lack of standardized measures. We've got a wide diversity of indicators that are labeled as a value, and therefore that creates a problem of validity, because you've got very competing notions of what a value is and how it should be measured. And using the European Values Survey, which I wanted to do because I wanted to track value change over time, as well as across different national contexts, meant that I couldn't use the Schwartz values battery, which is kind of seen as the gold standard approach to values, and is contained within the European Social Survey. I should point out that Schwartz values are individual values. They're kind of psychological dispositions. And there's a debate in the literature about the extent to which they can meaningfully be applied to political issues and political outcomes. I don't have time to go into that now, but that's the reason why they weren't used. Now, to do that, but to take my research forward, I came up with a number of approaches in terms of how you would go about creating values, so that I wasn't randomly making assumptions about what a value is and how it can be measured. So 4 primary assumptions that guided my research. One is that the values indicators that I'm using to create these latent measures should represent a high level of abstraction. In other words, they shouldn't be related to the political context itself. Okay, they should be abstracted from the political context. People should be able to identify with a value the questions that make up that value are not going to be defined by a political event or a political leaning. They're going to get at something that's probably quite stable and unlikely to change. Secondly, value measures should be multidimensional. So I'm looking for as many different questions as possible to go into creating my latent factors. Okay, so the more measures I've got, the more reliable, I'm more confident I can be that I'm getting at some underlying latent factor, and it's not just some random effect of the data that I happen to be looking at that time. Cross-national validity must be empirically established. Okay, this is a bit more controversial. So this says that the measures of because I'm looking at cross-national research, I need to establish that the concepts that I'm measuring can be applied in all of the countries that I've identified. And there are various statistical methods that we use in order to do that, and I'll take you through some of them in a moment. And finally, that the measures should be relatively robust to contextual influences, because I was interested in the impact of political context on the relationship between values and voting. I was specifically interested in whether countries that had higher rates of polarization produced a stronger relationship between values and voting. So therefore I had to be careful when using my measures that they weren't themselves going to be influenced by the impact of polarization, because otherwise I'd be creating these sort of endogenous issues of causality, where you couldn't be sure which direction the effect was going in. Okay. So in terms of measuring values as a latent construct, you're looking for commonalities that underlay responses to a specific variable. I mean, that's the basics of latent analysis, latent construct analysis. And this involves both an exploratory and a confirmatory stage. So the exploratory stage explores how many common factors may exist and what variables are likely to be relevant to my study. The confirmatory stage looks at the extent a known model based on the exploratory stage of my analysis, so the factors that I've identified in carrying out my initial analysis, and based on prior research as well, what people have done previously in this field using this data. And I'm testing whether that holds within the sample that I'm looking at. So I'm trying to confirm a hypothesis that this factor structure holds up. And there's various tests of validity for the model itself and for whether it holds up across different samples. So we've got various tests of invariance, which essentially is essentially defined by whether the same construct is being measured in different contexts. We've also got fitness tests, whether the data is a good fit for whether the model is a good fit for the data, and predictive power. So basically, whether it then does the job. Are these values predicting the outcomes that I will be expecting? So if I saw that strong egalitarianism was predicting kind of right of centre voting, I would probably be thinking there was something quite wrong with the measures that I had. And ultimately, this confirmatory factor analysis stage leads to a full structural equation model that I was presenting before, where you estimate a number of different pathways to the outcome variable, which in this case is vote choice. And to do this, you use latent variable statistical packages. So in my case, I used M+, because at the time that was the powerful package for this that the University of Manchester had. You could also use Lisreal. But increasingly, Stata is becoming used for these type of models, and it has its own package for running SEM models and confirmatory factor analysis models. And actually, in terms of an introduction to running these models, Stata is probably now better than these other models, simply because it's more user-friendly and more accessible. M+ takes us quite a lot of getting used to. It's got quite a complex coding structure and related to its data input as well. You probably need to go on a course for that. You don't necessarily need to do that for Stata, where you can just load up the statistical package for running SEM models. It's becoming increasingly used by most political scientists. Now, the first stage to go through was the exploratory factor analysis stage. So the exploratory factor analysis run on the 2008 pooled European data from the European Values Survey. And all potential value indicators were included in this first stage. And then I was going through a basic process of trial and error and elimination based on the performance of indicators in my model. So if there were factor loadings, if a variable was loading poorly into a factor, so in other words, the interpretation would be that this factor is not explaining very much of the variance in this variable, then that would therefore be excluded from the analysis. And the threshold was probably about 0.4 for doing that. But I was also making substantive judgments about whether a particular factor was relevant, or whether you can really make a claim that what was being tapped in this at this stage could be described as a value. And you're thinking about whether this is consistent with my expectations, but also with previous research findings and kind of methodological norms in the field. And the key factor here was that I was using exploratory factor analysis and not PCA, because PCA, as is known as principal components analysis, often overstates the strength of a factor. So I was trying to put quite a high threshold at the exploratory stage to make it more likely that those factors would hold up when I then moved on to the confirmatory analysis. In terms of the technical stuff, which some of you might be interested in, I used the WSLMV estimator, which is important if you're doing work in M+, which involves binary indicators, okay, because the standard estimator assumes continuous variables, rather than the WSLMV estimator is more flexible. It allows you to use different types of variables and use varimax rotation as well to maximize the differences. And again, this is estimated in M+. Now, unfortunately, I've had to copy and paste these tables in a bit of a hurry, so they're not as tidy as I'd like them to be. But this is essentially what the exploratory factor analysis looked like. So at the top, we've got sort of the eigenvalues. For those of you that might have done factor analysis before, you are looking for an eigenvalue above 1, essentially, as being something that is worth exploring, something that is as a kind of as a baseline threshold for saying that this variable, this factor is probably a genuine one. And you're also looking for a percentage of variance explained in the variables that is respectable. And as you can see, as it goes down, as you go down those factors, the variance explained goes down. But we were consistently getting kind of identifiable factors. Now I took out factor 2 because that included a set of variables that I decided to exclude. But we can see that in the first factor we were picking up various indicators related to traditionalism. So attitudes to homosexuality, attitudes to abortion, cohabitation, these kind of moral traditionalism values that have, and all of those loadings are over 0.4, so they were included in the analysis. And again, we've got the same thing going for sort of authoritarianism, where on factor 4, where the indicators aren't performing quite as well. Again, substantively, I'm making the decision that this is a relevant factor, that there's something here that's pulling this together, okay? Now, factor 3, which is benevolence, I ended up excluding that factor for 2 reasons. So despite the fact that it seems to be quite well performing in terms of the loadings, it ended up being excluded from my confirmatory analysis because I made the sort of substantive decision, it was quite a painful one at the time, that this was not something that I could justify based on the prior literature and theoretical assumptions. Okay, previous research had suggested that benevolence did not have much of an impact on vote choice or political outcomes. And in addition, there were some issues around the data not being available in in both waves of the data set that I was looking at, and I wanted to have some sort of comparative consistency. So I was making that research decision. Probably the most difficult decision at this stage was the fact that I wasn't able to generate a meaningful variable for security. Okay, I wanted to have a factor for security. But again, the European Value Survey didn't provide or didn't have a wide-ranging enough set of indicators to produce a value that could be justifiably defined as security. I could have forced it. I could have used things that were related to immigration and attitudes to, particularly attitudes to sort of overseas investment and things like that, but it was pretty weak in terms of how you'd substantively define it as security. In other words, I'd have been kind of convincing myself that this was a genuine value when it probably wasn't. It was probably tapping another concept. Okay, and in the end, I ended up settling on my confirmatory model that has the 5 values and the indicators of traditionalism related to moral traditionalism dimension, and we were using 3 items that ran on a 10-point scale that were capturing views on the acceptability of homosexuality, abortion, and divorce. Okay, so you can say that's narrowed down a definition of moral traditionalism. And an individualism scale that looked at issues about individual versus the state responsibility for action. An authority scale that focused on attitudes to child rearing, which is often used in research on authoritarianism. Attitudes to the kind of desirable attitudes that a child should be brought up with. So in this case, obedience, imagination, and independence. And conformity was looking at, again, the acceptability of using things like soft drugs, paying to avoid taxes, and avoiding public transport fares. So people kind of having a tendency towards conformity with rules. And finally, egalitarianism, which I had to make a substantive research decision to go with a single indicator, because the multiple dimensions for egalitarianism were not there in the European Value Survey consistently. So again, I've had to make kind of a compromise on my research in order to try and tap what I consider to be a critical indicator for my research, for the research questions that I'd like to ask about vote choice. Okay. And the end, the model looks like this. Oh, by the way, the reason I reduced the number of variables from the exploratory stage was to get a more robust model. So there, again, there's a kind of compromise made. compromised research decision, that in order to get a kind of clearer model that's more likely to be robust across multiple contexts, I've had to reduce the number of variables, which clearly reduces some of the statistical power. So these are kind of the research trade-offs that you're making. What you might ideally like and what you're probably going to have to kind of accept if you're trying to answer your research questions. And this is what the model looks like in the end. So these are the 4 factors, and the arrows at the bottom are the error terms going in to these variables. So in other words, it's the amount of variance that remains explained by those variables that is not accounted for by the factors. Okay, so it's the amount left over. So we've got the item indicators, and I've also correlated some of the factors together, again for substantive reasons, the assumption that in this particular instance that traditionalism and conformity were likely to be quite strongly correlated in the model. And the first stage of this process estimated in M+, a model for the pooled European sample. We then estimated the model for each country separately to check that the model at the pooled level was consistent for each country, that I was kicking up the same constructs. And the third stage estimates the model for each country simultaneously and generates factor scores, so I can compare the differences in the rate in these values between the countries in terms of raw scores. And the tests are applied to both the 1990 and 2008 data using the same estimator and a maximum likelihood missing data settings. Okay, they're the descriptives. I'll skip through that. Nothing particularly interesting, except that, again, these are not perfectly normally distributed variables. We have examples of quite skewed variables, particularly in conformity, as you might expect, considering that relates to willingness to break the law in some cases. Okay, so this is what the actual model looks like when you sort of churn it out. And what you're kind of looking at when you're putting together the results, this is the result for the pooled models, so for the whole European data set. The first thing you're looking for is that it fits the kind of statistical thresholds. So in this case, there's a CFI, which basically means the variance is accounted for in the data of over 0.95. So we've got CFI scores that are kind of not great, not perfect, but again, reasonable and consistent at 0.69 and 0.96, sorry, 0.969 and 0.962, so they're reasonably over that threshold. And again, the RMSEA, again, is a goodness of fits predictor. And you're looking for something that's normally under 0.05. Now, I should point out, a lot of this research, a lot of the literature on this is quite open-ended. And these, rather than compared with other statistical methods where you have quite hard and fast rules about statistical thresholds, a lot of the literature on structured equation modelling is quite varied in terms of where it sets its threshold. Okay, so some literature will set much harsher thresholds than this, much kind of more stricter statistical thresholds, and some will be considerably less harsh. The general perception is, though, that you're driven by substantive research decisions as much as you're driven by a sort of statistical judgment. Okay, so again, you're looking for factor loadings that are above 0.4 to suggest that there's actually something going on here, that this factor is explaining a significant amount of the variance in these variables. And again, this was consistent. I'm looking for stability across years. So if I'm seeing wildly different factor loadings, or I'm seeing kind of evidence of some factors just decreasing in size, then I'm probably not got a very stable model. I've probably got something that is going to only apply in certain contexts. But I'm also thinking about the substantive relevance. So does this tell me something? Are these factors working? Are they going to? Can I explain why some variables might be performing less well than other variables? That kind of thing. At the bottom here, we've got modification indices. Modification indices are a kind of dangerous thing because the model will churn out for you aspects that you can constrain that will basically improve your model fit. So if you create constraints or estimate further relationships between the different variables, it will improve your fit. But again, you might be doing that for statistical reasons rather than substantive reasons. So when I was looking at my these models, I was trying to find modifications that I could justify why these variables would be correlated with each other. Okay, and that's again about a substantive research decision that you're going back to previous research and trying to find evidence that would support that. I won't show you all the 30 national level models, but they did vary, and there were some data quality issues. Some questions were not asked in specific countries, and there were some poorly loaded items. Some of that was related to sample size variation. So the sample sizes between countries vary quite a lot, from 500 in Iceland in 1990 to 2,500, I think, in Germany in 1990. But there were only 3 examples of models that were below the fit thresholds. And these could be sort of substantively or methodologically accounted for. And the evidence was good, therefore, that the model held up in all 15 countries. And it was also there was relative consistency across time points as well. So therefore, the next stage, having established that these models basically held true in all 15 of my countries, the next stage is to run a multi-group analysis to see if we could have factor scores and measurement invariance tests to see how consistent my measures were and how the degree to which I could compare across countries. Now, factor scores for each country, when you run a confirmatory factor analysis, the number itself doesn't mean anything, okay, because you mean center it against 0. So in other words, 0 point shows you the kind of cross-national average, right, for each value. But but you can see the differences between countries compared with that mean point. So, for example, here are factor scores for traditionalism. In 2008, we can see that Portugal has the strongest score on traditionalism, the strongest positive score on traditionalism across the 15 countries, and Sweden has the lowest. Okay, and that, perhaps France and Spain, Netherlands are kind of clustered around the middle. And now in 1990, we can see the 1990 data allows us to see where we might pick up some change. So where we may see countries having become more or less sort of traditional, having more or less traditional values over that time period. And again, it's important to reinforce that this is only giving you relative measures. Okay, so I can't say anything about the general degree in which traditionalism might be rising and falling over this time, but I can say that it does look like Portugal is consistently comes across in my model as a country with the highest level of traditionalism. Okay, factor scores for authoritarianism immediately notice the fact that traditionalism has a far bigger range. So authoritarianism, we see less differences between the countries. They kind of quite cluster really around that 0 point, although it's also worth pointing out this is a binary variable, so the differences will be lower. And again, Portugal comes up as the strongest example of authoritarian, in terms of values of authoritarianism. And finally, I'm just going to show you individualism, because this is a good example of how you could see how relative change has occurred. Because you can see that in 1990, the UK has got one of the lowest rates of individualism according to the model, and come 2008, it's got the highest. Okay. Now, that may or may not be a statistical artifact. It may be something to do with the data, but it definitely shows you that this is something that's worth exploring when you go on to model kind of UK vote choice and run more complex statistics on this. And it allows you to demonstrate these kind of changes. Factor scores are a very useful method just for highlighting little differences that might give you a clue of what might be interesting, might be going on in your latent measures that may be worth exploring with more complex analysis later on. Okay, and the final stage then, test the comparability of the concepts, right? Do the contexts have the same meaning? Do our factors have the same meaning among different groups? So I'm running all the 15 countries in the same analysis, and I'm making assumptions about, statistical assumptions about the fact that the measurements will be the same. So the first stage, the configural stage of this testing assumes that the factor structure itself will be the same. So in other words, if I run this across 15 countries, I will see the same factor structure. I will consistently run models that are well-fitting models that demonstrate that I can identify these factors in these countries, that these exist. Okay? So there is a concept called individualism based on these variables that I can identify in each of these countries. That is consistent. The metric stage, which is the next sort of stage, it increases in severity of test, constrains the loading sizes. So you run a statistical test that constrains the loadings to be the same. So you make so it's testing this statistical assumption is, does this model still hold up if we assume that the loadings are consistent across each country? And finally, the scalar test, which is the error term, which again constrains all the error terms at the bottom. The arrows at the bottom that I showed you in the original model constrains them to be consistent. And the implications of failing to establish this effects on validity and the comparability of further analysis. Now, I managed to demonstrate configural invariance, so I was able to demonstrate that my factors were consistent in each country. What this table shows up here is that I wasn't able to establish either of the other tests. Okay, so I wasn't able to establish that the loadings were comparable and that the error term was comparable. And this had knock-on consequences to what I could then claim when I ran my structured equation models that related to voting, okay, because there are issues of comparability. So I can say I'm looking at the same concept, and I can say that this concept impacts vote choice here and here, but what I can't say is that with any kind of degree of reliability is that this value has a stronger effect than that value, because we haven't been able to establish evidence that these concepts are kind of equally made up in the same country of the same underlying principles. Okay, that statistically we haven't been able to establish that. We might be able to speculate that, but we haven't been able to statistically establish that. So measurement invariance, the more kind of harsher levels of measurement invariance were not established. However, this is a contested literature. Okay, there's a lot of people that say, again, this is an example of being led by the nose statistically, and that actually what you should be doing is looking at concepts and trying to justify whether what you have found is consistent with theoretical assumptions and consistent with prior research, and whether your kind of sociological imagination, if you like, has justified these findings. And variance itself can be a positive, provided that the factor structure is established, because you might actually want to see variance in your underlying values in this sense. You might want to see that there's differences between countries in how these values are interpreted. Okay. Not necessarily. So when you come across these kind of statistical roadblocks, this isn't necessarily kind of end game. Okay, you've got to think about what it actually means to your research, what it means to your kind of research questions, and how you then move on and reanalyze some aspects of your analysis, and perhaps go back and revisit some of your research questions. It comes back to this idea of research being a kind of iterative process, okay, not a linear one. So you have to revisit some of your assumptions. Okay. So the conclusion here is that statistical methods are not always a search for perfection. They're a search for what you can get out of it. You know, what are you trying to use statistics for? Okay. They're not the aim in themselves. They're just a tool for you to get at your research questions. And this is a long process, but I was able to use this as a measurement model for my main analysis, looking at voting. So you need to let your research questions lead you as much as the method. Okay. Make sure theory and analysis are kind of connected when you're doing this sort of analysis. And the more complex the method you use, the more important that is. Imperfect data and imperfect measures can still produce interesting findings as long as the implications and limitations of this are kind of acknowledged. And CFA is a powerful method for doing this. Cross-national validity of fuzzy concepts like values was a very kind of ambitious assumption I think I made at the start of this process. So I then had to revisit and kind of go back and think about whether my underlying assumptions themselves here were a bit ambitious. And factors themselves are essential for looking at kind of latent constructs, so things we can't get at directly, like values. And you need to consider the distributions and biases in the data. And finally, that factor scores will often give you something interesting and substantive findings and should not be ignored. Okay, because I actually made that mistake. I didn't originally use the factor scores. And somebody pointed out to me that I was missing a trick there. That there was the factor scores then allowed me to make some quite key substantive observations for my subsequent research. Okay, I think that covers everything. Thank you very much.